All right, so as soon as you finish your graphing radical functions worksheet, you should move on to this, solving radical equations. If you don't have the worksheet, you can ask the sub. The sub should have them. So I think that this lesson is going to be fairly simple, and I hope that you guys think it is as well. I hope that you guys think this is going to be the easiest lesson of this chapter so far, because as long as we follow these 4 steps and do all the math correctly, you should get your correct answers. So I recommend that you use a graphing calculator for this. You're going to have to check your work at the end, and using the graphing calculator is just going to make it a lot more simple. I'm going to be switching between the worksheet and my graphing calculator app so you guys can see my work on the graphing calculator. So let's go over the steps. So step 1 tells us to isolate the radical on one side of the equation. Then step 2 is to raise each side of the equation to the power of the index to eliminate the radical sign, right? So just real quick, index, if you don't remember, is the root of your function, right? So 4 here, 4 in that previous one. If you don't see an index, if you don't see a number here, it's 2. Right? When we're doing square root functions, we don't write the index, but the index for a square root function is 2. And so you're going to be writing the index, you're going to be raising each side of the equation to the power of the index to eliminate the radical sign. Then you're going to solve the remaining equation in step 3, and then step 4 is to check for extraneous solutions. So what that means is that we're going to check our work. We're going to plug in the solution that we get for our variable into our original equation and make sure that it actually works, because there are going to be a few on here that have a no solution, so we'll go over those. Now I'm going to try to go through this as quickly as possible with as much detail in the first couple. Once I do a few with a lot of detail, I will try to go through it kind of quickly. So on the first few, I'll explain my thought process and why I'm doing certain things, and as we do more and more, I'll give less detail and just kind of go through it, explaining what I'm doing, but doing it fairly quickly so that you guys can, so I can save some time on this video so that you guys can get through this worksheet as quickly as possible. All right, so the directions tell us to solve each equation and be sure to check for extraneous solutions. And we know that because of the 4th step, right? So step 1 tells us to isolate the radical on one side of the equation, right? So here's my radical. I want to make sure that this is the only term on the left side of the equal sign, right? So to do that, I'm going to get rid of this 5. Easiest way to do that is subtract 5 from both sides, right? So now I have the square root of x is equal to, and then 12 minus 5 is 7, right? So simple enough for step 1. Step 2 tells us to raise each side of the equation to the power of the index to eliminate the radical sign, right? So since I don't have an index, I know that my index is 2 here. So I'm going to raise both sides to the power of 2. If you raise a radical to the power of whatever the index is, it essentially just eliminates the radical, right? And I'm gonna walk you through this one, and I'll walk you through a cube root one as well. So first, if we're raising the square root of x to the power of 2, that is saying that we are doing the square root of x times the square root of x, right? And we know when we are multiplying radicals that if we have the same index, we are just going to multiply the radicands, right? So we get the square root of x times x, which is the square root of x squared, right? Since this has an exponent that is a multiple of our radical 2, we can take the square root of that, and the square root of x squared is going to be x, and then the exponent is going to be your exponent divided by the index, which is 1, so just x, right? So when we take this, when we have the square root of x and we raise it to the power 2, we're just getting rid of the radical, right? So I just wanted to show you guys why that works here, and I'll do it again for a cube root function, but we will continue. So when I raise the square root of x to the power of 2, I get left with just x, right? And in the other examples, when you're raising your radical to the power that is the same as the index, you're going to get rid of the radical, and whatever's left over, you're just going to have what's inside of the radical, because some of them are going to have, you know, a number and a variable. Some will have 2 terms, things like that. But just want to make sure that you guys understand. that when you raise it to the power, it's just getting rid of the radical. Everything inside of the radical, the radicand, just comes out. So x is equal to, and then 7 squared is 49, and then that's our answer, 49. So, oh, and then step 3 told us that after we raise each side of the equation to the power, step 3 was to solve the remaining equation. This one was pretty simple because we didn't have to follow step 3. When we did step 2, it just finished the example for us, but in the other ones, we're going to have to do some more math. Then step 4 tells us to check for extraneous solutions. So what that means is I need to plug in this 49 into my original equation and make sure that it actually works, right? So what we're going to do here is I'm going to substitute x with 49. So the square root of 49 plus 5 is equal to 12. So I know that the square root of 49 is 7. So I have 7 plus 5 is equal to 12. And 7 plus 5 is 12. So we get 12 is equal to 12. So it checks out. So this is our solution. X is equal to 49. Next, we have 3 minus the 4th root of m is equal to 0. So step 1 again tells us to isolate the radical on one side of the equation. So I need to get rid of this 3 right here. The easiest way to get rid of 3 is subtract 3 from both sides. So then I get negative 4th root of m is equal to negative 3. So now step 2 is to raise each side of the equation to the power of the index to eliminate the radical sign. So I need to raise both sides to the power of 4. And when I raise negative 4th root of m to the 4th power, it's getting rid of the radical, but also I'm going to write this out for you guys so you guys understand, but this is when we're raising negative 4th root of m to the 4th power, we have negative 4th root of m times negative 4th root of m times negative 4th root of m times negative 4th root of m, and this is going to essentially eliminate our index, but what's also going to happen, negative times a negative is a positive, times a negative is a negative, times a negative is a positive. So when we multiply these 4 out together, we get positive. So we just want to make sure that you guys understand that, because I'm about to write what it is simplified. So this is going to be just m is equal to, and then negative 3 raised to the 4th power. That's the same as negative 3 times negative 3 times negative 3 times negative 3. So I want you guys to do this on your calculator, but I want you to know something real quick. When you're using the calculator, I don't want you to write negative 3 and then exponent 4, because you're going to get the incorrect answer, right? So this calculator is telling me that negative 3 raised to the 4th power is negative 81. That's not correct, because a negative number times itself 4 times is going to give you a positive number. So don't make the mistake of just writing negative 3 and then raised to the 4th power, because the calculator is following order of operations. So what it's doing, it's raising just 3 to the 4th power and keeping the negative sign. Excuse me. So that's why we got negative 81. So what you need to do when you're raising a negative number to an exponent, you need to write parentheses and then the number. And if you look at the negative sign right here that I just highlighted, it has parentheses around it. So it's telling you that if you're going to do something with a negative number that follows the order of operations, you need to put parentheses around that negative number. So negative 3 raised to the 4th power, this is going to give us the correct solution, which is actually 81. Excuse me. So the negative 3 raised to the 4th power is positive 81. So m is equal to 81. Now we need to follow step 4 to check for extraneous solutions. So I need to plug in 81 for m. So I'm going to rewrite my equation, except I'm going to replace m with 81. So this is 3 minus the 4th root of 81 is equal to 0. So let's go find out what the 4th root of 81 is. So what you're going to do is you're going to click math. You're going to go to the 5th option. You're going to change on your calculator. If you're not using this app, if you're using the class set of graphing calculators, you're going to have to change A and S to 4, right? So then I'm going to type in 4 right here, and then I'm going to type in 81, and the 4th root of 81 is 3. So this is So this is 3. So this we're left over with 3 minus 3 is equal to 0. 3 minus 3 is 0. So 0 is equal to 0. It checks out. So our answer is m is equal to 81. All right, so now we're moving on to number 3. This is going to require, now we're actually going to use step 3. We're going to solve the remaining equation, because before we just, as soon as we did the, we raised to an exponent, we got our answer. All right, so here, first thing, we want to isolate the radical. So we're going to subtract 10 from both sides. You get the square root of a plus 7 is equal to 1. All right, next you're going to raise both sides to the power, which is the same as the index. Index is 2 since we don't see it. So both squared, this gets rid of my radical. So I have a plus 7 is equal to 1 squared is just 1, right? 1 times itself. 1 times 1 is 1. And then, excuse me. Now we're going to follow step 3, which is solve the remaining equation. So we have a plus 7 is equal to 1. So I want to get a by itself. I'm going to subtract 7 from both sides, and I get a is equal to negative 6. So now step 4, check for extraneous solutions. I'm going to plug in negative 6 in for a and make sure that it checks out. So 10 plus the square root of negative 6 plus 7 is equal to 11. Well, negative 6 plus 7 is 1, right? So I have the square root of 1. 10 plus the square root of 1 is equal to 1. And sorry, it's supposed to be equal to 11. I forgot to write the extra 1. And 10 plus the square, we know that the square root of 1 is just 1, right? And then we know that 10 plus 1 is 11. So 11 is equal to 11. It checks out. Our answer is a is equal to negative 6. Number 4, we have square root of 6w minus 5 plus 10 is equal to 3. So step 1, isolate our radical. Subtract 10 from both sides. I'm going to write the index over here just so I don't have to repeat it later on. So then I'm left with the square root of 6w minus 5 is equal to 3 minus 10 is going to be negative 7, right? So I'm going to raise both sides to the power that matches the index, so squared, and I'm left with 6w minus 5 is equal to negative 7 raised to the second power is 49, right? Negative 7 times negative 7 is 49. And then we're going to solve the remaining equation. So I'm going to add 5 to both sides. I get 6w is equal to 54. And then divide both sides by 6. And I get w is equal to 9. So now I did all the math correctly. I'm going to check for extraneous solutions. So I have the square root. Remember, I'm replacing w with 9. So I have the square root of 6 times 9 minus 5 plus 10 is equal to 3. All right, so 6 times 9 is going to be 54. So I have the square root of 54 minus 5. 54 minus 5 is 49, so I have the square root of 49 plus 10 is equal to 3. The square root of 49 is 7, so I have 7 plus 10 is equal to 3. And then 7 plus 10 is equal to 17, is equal to 3, right? So this 17 does not equal 3, right? This does not check out. So this is a no solution. And I know, so some of you guys might be thinking, when you do the square root of something, you get plus or minus, right? Negative 7 plus 10 does equal positive 3. However, when we're working with radical equations, we're just going to look at the principal root, which is the positive root, right? So that's why this one is a no solution. All right, next, we're going to move on, excuse me, we're going to move on to number 5. So number 5, we have negative 36 is equal to negative 9 times c minus 12 raised to the power of 1/2. And when something is raised to the power of 1/2, it's the same thing as the square root, right? Because, so this is the power, flower power. So this is the power, and this is the root, because under the ground, under a flower is roots, right? So this would be the second root of something raised to the first power. So it's just a square root of something, right? So whenever you see 1 over 2, it's a square root. If you see 1 over 3 as an exponent, that's cube root. If you see 1 over 4, that's the fourth root. So you have a couple options here. You could just change this to a radical, or you can keep it the same. I'm going to show you guys both ways real quick because it'll be the same thing. So let's go ahead and follow step 1. So step 1 tells us to isolate our radical. So we're going to divide both sides by 9, negative 9. Negative 36 divided by negative 9 is going to be positive 4. So I get 4 is equal to c minus 12 raised to the power 1/2. Now you can change this to a radical, which would be the square root of c minus 12, right? 4 is equal to c minus 12. Again, like I said, if you have 1/2 as an exponent, it's just the square root of whatever is in parentheses, or whatever the exponent is operating on, if there was no parentheses. So now I have 4 is equal to the square root of c minus 12. I'm going to raise both sides to the power of 2, right? And then I get 4 squared is 16, so 16 is equal to c minus 12. I'm going to add 12 to both sides, and I get 28 is equal to c, or c is equal to 28, right? And then you can plug it in to the original equation to make sure that it is correct. Step 4, to check for extraneous solutions. All right, so we have negative 36 is equal to negative 9 times c. I'm replacing c with 28, so 28 minus 12 raised to the power 1/2. So let's go ahead and check this out. So I'm going to use my calculator to do this side. So I have 28 minus 12 times negative 9. Remember, I'm following order of operations, raised to the power 1/2. So I'm going to do 28 minus 12, which is 16, right? 28 minus 12 is 16, raised to the power 1/2. So I'm going to do 16 raised to the power 1. 1 divided by 2, or you could do 0.5. Like I'll show you, 16 raised to the 1/2, 16 raised to 0.5. Same thing, it's 4. So this turns into 4, right? So I have negative 9 times 4. Negative 36 is equal to negative 9 times 4. Negative 9 times 4 is negative 36. So this checks out. This is the correct solution. Now, real quick, I'm going to do this part real quick. Let's go back here, and let's say that you didn't want to waste time and change this into a radical. So you can still treat this as if it was a radical, and you would raise it to the exponent too, right? So, because step 2 was to raise both sides to the power that matches the index. Well, if you raise something to, if you have a term raised to a power raised to another power, this is the power rule of exponents. You just multiply the exponents, right? So we know that 4 squared is 16. And then we're going to multiply these two exponents. 1/2 times 2 is 1, right? Well, we know that you know that 0.5 times 2 is 1. Or if you wanted to make this into a fraction, you do numerator times numerator, denominator times denominator, which is 2 over 2, which is just 1, right? So that means that this becomes c minus 12 raised to the first power, which is just c minus 12, right? So you can skip that step of changing it to a radical. If it helps you, continue doing it. But this will save you some time if you can just guess that you're going to raise it to the exponent that is in the denominator. And then you would get the same thing, add 12 to both sides. You get 28 is equal to c. And this checked out, right? When we did the math, it checked out. All right. So number 6, this time I'm not going to change it to a radical. However, this would be the cube root. But I'm just going to raise it to the exponent 3, right? Because I know that 3 is my root. So I'm going to subtract 11 from both sides, right? I have to isolate my radical first. I get 7p minus 1 raised to the power 1 over 3 is equal to 7 minus 11 is going to be negative 4. So now I'm going to raise both sides to the power 3. When you multiply these two exponents, you get 3 over 3, which is just 1. So this becomes 7p minus 1 is equal to negative 4 raised to the third power. I'm going to do that on my calculator. So I'm going to put in parentheses negative 4. And then raised to the third power is negative 64. All right, so then I'm going to solve the remaining equation, add 1 to both sides. You get 7p is equal to, I'm going to leave myself a little more space. 7p minus 1 is equal to negative 64. I'm going to add 1 to both sides. I get 7p is equal to negative 63, right? Divide both sides by 7, and you get p is equal to negative 9. All right, so let's check if this works. So I'm going to replace p with negative 9. So I have, in parentheses, 7 times negative 9 minus 1. And then this is going to be raised to the 1/3 power. Plus 11 is equal to 7. All right, excuse me. So 7 times negative 9 is negative 63. And then negative 63 minus 1 is negative 64, right? 63 minus 1 is negative 64. So we have negative 64 raised to the power 1/3 plus 11 is equal to 7. And then if you want to do negative 64, remember parentheses, negative 64 raised to the power 1/3, you get negative 4. So this is negative 4. So I have negative 4 plus 11 is equal to 7. Negative 4 plus 11 is 7. So we get 7 is equal to 7. It checks out. So this is the correct solution. P is equal to negative 9. Number 7. All right. So now we have a 4th root. So the exponent that we're going to raise in step 2 is going to be 4, right? So I'm going to isolate first. So add 9 to both sides. I get the 4th root of 8k plus 12 is equal to negative 11 plus 9 is negative 2. I'm going to raise both sides to the 4th power. So you can do on your calculator, parentheses, negative 2 raised to the 4th power, you get 16. So I get 8k plus 12 is equal to positive 16, right? I'm going to subtract 12 from both sides. And then I get 8k is equal to 16 minus 12 is 4. Divide both sides by 8. And 4 divided by 8 is 1/2, right? So k is equal to 1/2. So we're going to go ahead and check for extraneous solutions. Make sure that this is the correct solution. So, excuse me. So I have the 4th root of 8 times 1/2, right? 0.5, 1/2, you can do it either way. Plus 12 minus 9 is equal to negative 11. So negative 8 times 1/2 is going to be 4, right? So I have the 4th root of, so this is 4, and then 4 plus 11 is 16. Excuse me. So we're going to do the 4th root of 16. Math, 5 changes to 4. 4th root of 16 is equal to 2. So then I get 2 minus 9 is equal to negative 11. And 2 minus negative 9 is negative 7 is equal to 11. This does not check out. So k is equal to 1/2. So again, with this one where we have no solution, if you would get plus or minus normally, but since we're only working with the principal root, that's why this is a no solution. All right, number 8. So we have negative 4 times the square root of 43 minus 3x plus 18 is equal to negative 2. All right, so first step, get everything, I get the radical on its own, isolate. So I'm going to subtract 18 from both sides, and I get, when you subtract negative 2 by 18, so you subtract 18 from negative 2, you get negative 20, right? So this gets eliminated, and then it's equal to negative 20, and then you're going to divide both sides by negative 4, right? So then I get the square root of 43 minus 3x is equal to negative 20 divided by negative 4 is positive 5, right? So next, we're going to raise it to the exponent that matches the index. Our index is 2. So I'm going to raise both sides to the second power. And I get 43 minus 3x is equal to 5 squared is 25, right? So this is equal to 25. And then you're going to solve the remaining equation. So you're going to subtract 43 from both sides. You get negative 3x is equal to 25 minus 43 is negative 18. Then you're going to divide both sides by negative 3. And you get x is equal to, and negative 18 divided by negative 3 is positive 6. So let's check for extraneous solutions. I'm going to erase this so I can see clearly what I'm doing. All right, so I have negative 4 times the square root of 43 minus 3 times 6 plus 18 is equal to negative 2. All right, so 43, so 3 times 6, that is going to be 18. So 43 minus 18 is going to be 25. So I have negative 4 times the square root of 25 plus 18 is equal to negative 2. Square root of 25 is 5. Negative 4 times 5 is negative 20 plus 18 is equal to negative 2. And then negative 20 plus 18 is negative 2 is equal to negative 2. Checks out. So this is our correct answer. All right, so now we're on the back side. I'm going to look through these and see which ones are difficult. I'm sure that you guys can now go through these. If there's any of them with some kind of special circumstance that we haven't covered yet, I will make a video of it. I'm going to look through them right now, and just to save time on this video, I'll let you guys go through this on your own. I'm going to post the answers on Canvas, so I'll fill in the answers into this worksheet and upload that worksheet to Canvas. Please send me a message on Canvas if you have any additional questions on anything we covered today.